Hello, my name is Robert Forstad, and I'm really thrilled to show you a web application I made called Mint Condition. So there's a $5 billion market every year for sports memorabilia, and I think there's a problem right at the heart of the market that's ripe to be tackled with data. So most people are selling trading cards. They look like this, and the value of a card hinges largely on the condition that it's in. So this card in perfect condition would be worth upwards of $2 million. This card in the worst possible condition recently sold for $10,000. So the takeaway is that the condition of the card can drive the value quite a bit. The problem is that the way that we calculate condition right now or evaluate it is not very good. Most of the time, we simply have two human amateurs debate with each other about the condition of the card. The problem is that I'm going to show you data that they're highly inaccurate when they do this, and furthermore, that they're highly unreliable. This means even if the guy on the left actually has the right grade and the guy on the right has the wrong grade, they still can't make a deal because he can't convince him that he has the right grade. The other solution is to send the card to an expert annotator. These annotators are highly accurate. The problem, as you can see, is that the cost and month-long wait are highly prohibitive for most transactions on the market. So to quantify the problem for you, right now on eBay, there's 7 million trading cards simply listed as ungraded, as if we didn't have a grading system at all. So my solution is to think of this as a data problem. I was able to mine about 90,000 expert graded cards from historical auction data. You can see the card on the left, and the red rectangle has the expert grade on the top. So when I crop this off, now we have a computer vision problem. And we know that computers are really good at learning to see as accurately as the experts, but much quicker and much cheaper. So that's what I tried to do here. I trained a machine learning model, specifically a convolutional neural network known as ResNet, and I trained it from scratch to predict the grade assigned to the card by an expert. So this is a 5-shot classification from mint all the way down to 4. There were 3 interesting data problems, I think, here. One of the problems is that some cards, like baseball cards, are much older on average than other cards, let's say basketball cards or hockey cards. And that means on average, they tend to be in worse condition. So I went through a lot of effort, and this involved a lot of data wrangling at the data set level to make sure that what my model was identifying was the condition of the card and not things about the sport. So I want to see that this card is scratched and not that this guy is holding a baseball bat. Everything involved in training a good model from scratch was involved here. One of the most interesting steps was a form of data augmentation, where I can randomly disturb the input images in various ways. There's several interpretations of what this does. One of the ways you can think of this is making the model really robust if a user uploads a picture in a highly unusual orientation. Finally, my best baseline is people, because I'm claiming this works better than people, which is what we have right now. So it was really important to me to actually experimentally compare my model to people. So I went out, and in 2 experiments, I tested more than 30 amateur humans. I made them grade trading cards. And when I evaluate my model, that's what I'm going to show you. So in this figure, up is always better, blue is people, green is my model, and I have 3 main results. 1, my model roughly doubles the accuracy of the average human amateur, suggesting I can give you a quick, good enough estimate of the condition of a card. 2, when 2 human amateurs grade the same card, they're highly unlikely to agree with each other. By contrast, my model's always going to agree with itself. So stepping back, not only can I give you a better estimate of the condition of the card, but I can help you have an objective standard to agree with each other and actually execute a transaction. Now, this is all well and good, but it's true that it takes effort to log onto a website and get the AI to grade a card. So are people really willing to do that? So I ran a second experiment where after people graded a card, they could either simply go on to the next card, or they could take the effort to optionally see what the AI graded it and decide whether or not to revise their grade. So what I want to point out is that most people, although not everyone, were interested in taking the effort to see the AI grade. So here's what the application looks like. There's 2 ways users can interact with it. One thing they can do is simply upload a picture of a card. Something even more useful they can do that they're usually going to do is scrape a card live off eBay. This is a real live eBay auction URL, and we just scraped it in real time. You can see the model was, the card was identified by an expert as mint or 9 condition, and my model got it right. Some optional features to help out involve adding a watermark to verify the grade, say in an online auction. Seeing how confident the model is, which can tell you whether maybe you need to upload a different picture. And you can also get a heat map of what the model is seeing. This has a couple uses, but you can think of this as adding explainability to the model so that you can understand why the model might have given a card the grade that it did. So a little bit about me. I spent my graduate school mining over 100 million social media posts. And the idea was to see whether your large-scale everyday behavior says something about who you are as a person. So I was typically training machine learning models, supervised and unsupervised, to say something interesting about you, like what decisions might you make if you actually went in the lab. And then I would follow up and actually conduct the relevant experiments. So this means you can think of me as having about 5 years of experience with a variety of supervised and unsupervised machine learning techniques, especially natural language processing and social media mining, but quite a broad array. I think the other way you can think of my background is that I've really had to work all the way from scraping my own messy, large-scale, real-world data and cleaning it in reasonable ways, all the way to drawing kind of strong publication quality inferences from that data. And so that's really what attracts me about data science, going all the way from sort of cleaning the data to learning something interesting from it. And that's what I'd be thrilled to do in industry. So specifically, I'd be thrilled to join companies who are interested in building products that help understand how people behave and why. Thanks for your time.